Alright, so this video is going to be part 4 of our integral test practice. Okay, so this time I wanted to do just a series that was drawn out, okay? So that's the only thing that's different about this video. So we want to prove the series 1/4 plus 1/6 plus 1/8 plus 1/10 on and on is convergent, or that it's divergent. Okay, so the first thing that we need to do is put this into a sum, okay? Put this into a sum notation. Okay? And to do that, we need to kind of come up with an equation here. Okay? How are we getting from this first term to the second term to the third term? Okay, well, these are just going to be multiples of 2, right? This is 4, 6, 8, 10, 12, but we're starting off at 4. Okay? So, of course, the numerator is going to be 1. Obviously, right? The numerator is not changing at all. And we're doing multiples of 2. So we're going to have a 2n in there. Okay? But to make this work, we have to account that our first term is 4. So if our first term is 4, as it sits right now, we have a 1 over 2 times 1, which is 1/2, right? But if we want a 1 over 4, all we have to do is add 2 to this denominator. And you'll see that this also works for our second term, for our third term, our fourth term, and our fifth term, right? For example, 1/6, right? This is our second term. Well, if we plug in a 2 here, we have 2 times 2, which is 4, plus 2 is 6. Okay? So you get that 1/6. For our 1/8, right? That's our third term. 2 times 3, that's 6, plus 2 is 8. So we get that, okay? So this ends up working. Now, can we just, this doesn't look like an easy P series or a geometric series, so we're gonna have to use some tests, and the first test, of course, is to do our test for divergence. Now we can do that by taking the limit as n approaches infinity, and we take that of 1 over 2n plus 2. Now you can tell that that limit is going to equal 0, so the test for divergence isn't going to tell us anything here. What we're going to need to do is perform the integral test, right? So we're going to be using 1 over 2x plus 2, okay? We just substitute that x in for the n, pretty much it. Okay, and let's try to do it from 1 to infinity, okay? And to do that, of course, we need to see if this is continuous, positive, and decreasing along the interval, okay? So is it continuous? Well, these are positive values on the bottom, and of course we're only inputting positive values, so there's no way that this is going to be a 0, so it is continuous. Is it positive? Well, like I just said, we're inputting positive, and the whole thing is just positive values, so yes, it is positive. Is it decreasing? Well, as x gets bigger and bigger, this denominator gets bigger and bigger, which means this fraction gets smaller and smaller. It is indeed decreasing. So now that we've identified that it's continuous, positive, and decreasing, we can do our integral. So we do our integral from 1 to infinity of 1 over 2x plus 2 dx. Okay? So to do this integral, now we set up our limit. Okay? Set up our limit as t approaches infinity. The integral from 1 to t of 1 over 2x plus 2 dx. Okay? And to solve this, we're going to need to do a u substitution. Okay, so we do a u substitution with u equal to 2x plus 2, du equal to 2 dx, but we don't have a 2 up here, so we can do a du over 2 equals x dx. Okay? And then we need to do our bounds. So if x equals 1, actually I could do this right next to here, this might look a little better. If x equals 1, then u equals what? Well, if we plug in a 1 for x here, 2 times 1, that's 2 plus 2 is 4. And we plug in a t, then we'll get a t back. So we now have our bounds. Okay? So we can do now the limit as t approaches infinity, the integral from 4 to t of, well, remember we had that du over 2, so we got to pull that 1/2 out. We can have a 1/2 right here. Okay, and now on the inside we'll have a 1 over u du. Okay, that of course is just natural log of absolute value of u, so we get the limit as t approaches infinity. We're just going to have 1/2 natural log absolute value of u evaluated from 4 to t. These are all positive values, so we can get this absolute value to get out of here. Alright, and of course now we can just do our evaluation step. We do that right over here. We get the limit as t approaches infinity of 1/2 natural log of t minus natural log of 4. And you can see that as t approaches infinity, this whole thing is going to approach infinity. So, by the integral test, we can prove that this series is divergent. Alright, and basically that's going to be it, okay? So, all we had to do for this problem, like what was actually different about this problem, was we had a written out series and we had to convert it into a sum, okay? And we put it into a summation notation, I guess you could say. And then from there, we did basically what we did in every other problem thus far, alright? And we found that by the integral test, the series is divergent. And that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the integral test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.